Alright guys, so I want to make this last video about the motion controls as far as like registration and about how to go about it, right? Because now what I've done is I've made a slight bit of modifications. If you recall in the last 4 videos, what we did is we had this first lead scenario right here, right? And we basically used it as the same commands as, well, what Rockwell recommends, and I'll show you what they recommend. Right, you pull up instruction help and you can see the ladder logic continuous registration detection right here. That is what they recommend for continuous registration. Alright, now also what I've done too is I've added a second one for and I'll show you this. Let me pull this up just a tad bit more so you can see it a little bit better. So I've added a second one, and this is for the negative edge. So I'm reading the positive edge and I'm reading the negative edge. Now again, this is using a servo. Basically I just have like a 4-inch diameter wheel, and what I've done to actually add complexity to it is I've added the reflective tape roughly around about an inch wide or an inch long, so that it reflects the tape. The reflector that I'm currently using reflects the tape, and that's going to be off of the input registry, right? So currently I'm using input 1 and input 2. All I did was actually basically parallel that actual first command we did, or the first registration input, parallel that same input to registration 2 or registration 1 on the actual terminal block. Now the reason I'm doing that, and I'll justify this as just the way it is. Alright, so using a periodic task, come over here, I'm using a periodic task. I want you to understand that the trigger is going to, as has always been since we started, access registration 2. And that's for the servo, the trainer servo that we're using. Now currently the task will execute if there is no registration. It will execute within 5 milliseconds, and the reason for that is going to be the disarm. Now the disarm is because I'm having the disarm inside of the actual registration, again the registration task, because of the simple fact of all the components of the registration should be together. And so therefore if there's no registration event, I want to still have this registration disarm happen. Now it does happen again. That's basically why you come over here and you say I want this to execute within 5 milliseconds if there is no registration command. That's basically how I got the timing from that, and basically why I'm going off of that. Now let's talk about this a little bit deeper. So alright, we have the registration. Alright, we talked about that. We had this rung 0 from the very start. What I've done, instead of changing the using the registration input directly or the registration event directly, what I've done is I've actually looped that over, and I said, okay, I'm going to use the registration event, but I'm also going to make sure the servo is running, and then I'm going to trigger a auxiliary bit outside of the using the direct input. Now I'm going to show you a trend that I have pre-built, and we're going to watch all of this. Okay, so I've called this registration trend. You can see all of this is currently right here. I do have the motion app ready to go, so we can actually watch all of this running. And what I'm going to do is give you the full-fledged actual opinion of basically what this thing is. So keep in mind, my scenario is basically the way I have it wired. The most important thing you can understand about registration wiring, and I want to bring this to a point, is the way the input is actually wired. Are you using the normally open side of the switch, or the normally open side of the photo eye, or the normally closed side of the photo eye? Are you transitioning when it makes the reflector or when it breaks the reflector? That is the actual thing you need to realize. Okay, I'm going to show you this. Okay, so I'm actually doing this when the photo eye is made. I'm coming in giving this registration. Now I'm giving the registration event. Alright, so you know previously that I had a GSV pulling the actual registration as soon as the command, the actual ARM went PC, went process complete, then it would grab the actual servo's position. Down here we have this down here where we said, okay, we're going to then take the servo position and move it into the come over here and then subtract it to get the product length. I've since then said, okay, being that we're going to use registration positive edge, registration negative edge, we're using registration input 1 or 2, and we're using registration input 1. What we're going to do is we're going to actually take registration position when the registration position happens on registration 2, and then we're going to subtract the registration position 1, and then we're going to get our difference between the two. Now let me show you this so you can see it running. Okay, we're going to come over here, we'll hit the reset, we'll hit start. Okay, this will start the system. Now we have a start command. Alright, now we're running, and I want to show you this running. Alright, so now we're coming in, and I want you to actually watch so you can see the registration. It's going very slow right now. Let's speed this up just a little bit so you can see how fast this stuff is running. Now you see there's very, and let me pull this up a little bit closer so you can see the actual target. So this PC bit, you're not going to see transition. It is happening very fast. And in an L7 processor, your motion is going to happen first, okay, before the scan happens. So the good side to it is we're using an event instead of a periodic task this time, so we're going to get the fastest execution possible. But you do see this number as actually changing, and that number is pretty much very much valid, right? It is slightly different though. I want you to notice that slightly different from just using registration input 1. And why is that? Because of the simple fact of the way they are working. Okay, so we're using both of the inputs are wired at the same time, same way. So I want you to come over here and look at the trend, and you can see the registration input is the bit that I made called registration input is the red marker. The actual servo registration 1 input status is the actual purple marker, or fuchsia color if you want to call it, and the next one is going to be the trainer servo registration 2, which is the white color. You see those are all triggering at the same time. So this is very important because it's understanding that the trigger is happening at the same time. Okay, so I separated the actual registration. I made that auxiliary from that, right? Which again, when we come back and look at this, you can tell my registration status is what's triggering this registration bit. Okay, keep that in mind. So I want you to understand the most important thing here is going to be that. Now, also too, the registration difference right here is exactly what it should be, right? Okay, so you have a registration difference, and the registration difference is where we're getting over here. This is the reg difference. You can see that. That's basically a 0.86. That's going to be constant the whole time because we're very much in the point of, you know, having that. Well, it's pretty valid. You can see it hops up a little bit here and it changes a little bit there. Again, so these two are the product registration difference and the product length difference, right? So that's one is using the difference between the two is one is being, I guess, using the registration position 1 and position 2 and minusing is subtracting those two together. Now the next one down here is using just registration 1. So it's a little bit different, but again, and if you're noticing down here the PC bits, we cannot track the PC bits as much as we would like because of the simple fact of the way the PC bits are. We're currently trying to get a periodic task or a periodic scan using the actual trend. We're trying to get that at 1 millisecond, but however, the very first thing that takes precedence in a L7 or L6 processor is motion, not your trending. So you're not going to get everything you want to see here. I want you to notice too, watch this. This is going to be very interesting to you. So let me just open this up, open properties up, and let's change this to let's actually open the registration this is going to be the registration event. Watch, I'll change to registration 1 as my trigger point, and watch this. This is going to change which one of these is dominant. So you see that trigger right here, changing that to registration 1, that's going to mean whichever one of these is actually from registration input 1 to registration input 2, that's going to change which one of these is more dominant. You see that the PC bits change a little bit, and now it's based upon, again, this data is not really reliable, again, because you cannot scan it as quick as it needs to be scanned. You would actually need to scan this as like real time, and it needs to take precedence over what is actually called the actual scan rate and the way that scans are done. Keep in mind, motion is updated in this process, again, every 4 milliseconds, and that's taking precedence over everything. Okay, so again, then we're coming in doing that on our actual product registration, which we have converted from, if you watch the other videos, from the actual periodic task to an event-driven task. Now again, you see that it's actually taking precedence. Now, is it actually changing the way things are read? No, it's not. Let's look at we're still seeing the same exact triggers because of the way we have things set up on our arms and disarms. Now, why am I using the negative side, or the basically an XIO up here and an XI right here? If I go to I'm using XIC here, and right here I'm using XIO. Why am I doing that? Okay, now I explain this to you is because, I'm using also the arm of each one of these. Now if I were to choose to use the arm of this one of these instructions would error out. So just keep in mind when it comes down to registration that when you're doing these in the same routine or the same basically rung together, or even in different ones, just keep that in mind, that if you're using the same servo, you need to use different inputs. And when you're using different inputs, you're going to start using different ARM instructions, right? So ARM status, the ARM status should reflect which actual input you're using. And that's the input on the K6K, again, how the K6K is actually armed, or actually read, right? So that's, again, using the registration input. Now again, you're not seeing these triggers like they should be, because again, it's so fast. And don't worry about that. This is just because we're looking at a graphical interface. Again, motion is so fast, it takes precedence over all of that. You see, all of this is steady working. Now, I talked about I'm using the registration input position 1 and position 2. I want to show you that inside of the servo. So you go to servo tags, and you can see the registration input right here. This is the registration input 1 and registration input 2. Now, how do I know that? Again, that is just because this is the time it happened. This is the actual position it happened. So you can actually reference the times too when the event did happen, right? And that's very, very common. So let's change this back, and let's change this back to what we had, registration input 2. Let's cycle that, and let's get our times back the way they should be. Again, we don't have no overlaps. Everything's working perfectly. When we come down here, you can see that everything is working as it should be. Now, let me stop this, and because we did talk about the actual why we are triggering. Remember, when we come back over here, we're triggering and allowing this execution of this routine, or this task. We're allowing that to happen every 5 milliseconds if no registration event happened. Why are we doing that? I'm going to explain this right now. We're coming in, and let's just say we stop. Okay, let's just say we come over here to our HMI, and we hit a stop command. I'm going to issue a stop command, and then I'm going to come over here to my program, and then I'm going to go to disarm, and then you'll see it has disarmed. But again, now, so if I were to start it, let me start it real quick. Let me see if I can't get it back over here. Okay, so let's stop it now and let's jump over to our program, and you'll see these transition. You see that those bits transition, and that's our disarm. Our disarm had to actually transpire. It had to work. It had to disarm the actual registration. All we did was disarm the registration because there's no activity, right? So we don't want to arm any activity. Now, I talked about also the reason I'm doing that is because, or the reason I'm getting by with that is because of my actual execution of events. Again, if there's no events, we're going to execute every 5 milliseconds. We're able to do that. Again, we're able to do that only because there's no events happening and we want to disarm that. We've disarmed everything. Everything's good. There is no arm instructions here. If we were to start the system again, oh, and let's verify that you can see the positions are not changing. Let's come over here. Let's come over here and start the system. We're starting the system now. And then we're going to come over here, and then we're going to go back to our system, and we're going to see that the ARM instructions are actually armed at this point in time. And that means they are monitoring the inputs, the actual registration inputs. Again, I know these videos are kind of long and they're very detailed, so please understand, if you have not watched videos 1 through 4, go back and watch videos 1 through 4, because they are very much a valuable thing in leading up to where we are today. I am making this video today to show the facts of how this instructions works, some extra things you can do as far as like when you're doing, you come in here and you do event-driven task. Some things that are important, again, when it comes to executing the task anyway, if a registration doesn't happen, if you have auxiliary controls in there to disarm or do other things. Again, that's very important because you could be doing just about anything in this routine and you want it to actually scan and have its functionality inside of that routine, if it is actually inside the routine. And then we talked about, again, how are we using that? How are we using the registration position 2 and registration position 1? How important that is to get the actual speed or the actual position right here for the registration difference. Now we can equate that registration difference based upon our gear ratio, how long our conveyor is, how long the product sensing device is, whatever the case may be. If I speed this up, it has the same exact properties, right? Now, just to show you that that is speeded up or sped up, you can see that did speed up here. Now you see yellow, which is the product event, that is the one that is using registration 1 only. The second one, this turquoise or this light blue, is the registration difference. You see, it's a lot more. I guess if I would say this correctly, it's a lot more consistent. So, and the reason it's more consistent is, again, when we come down here and look at the actual controls to this, again, we're using the registration position against the other registration position. Why are we able to do that? Why were we not able to do that before? Before, we only had one registration, right? We weren't looking at leading edge or positive edge and negative edge. We weren't doing that. We just had the leading edge, so we had to go off of what we had. And again, you're getting a lot better instruction, you get a lot better control, a lot better atmosphere doing the actual registration position versus the registration position if you're using 2 different registration points and you're using positive and negative. Again, when it comes down to it, we could have used 2 positives, but again, that doesn't make any sense when you have a photo eye transitioning. We have one single photo eye transitioning from a positive to a negative, right? We have one input transitioning. That's the only thing that makes sense, right? You wouldn't have, if you had 2 separate photo eyes, you could do 2 positives, or 2 separate photo eyes, you could do 2 negatives. But you have one photo eye, you have to understand the order of operation and why you would do such, right? So I wanted to pass this video on. Also, you know, I make these videos for myself too, so when I go back and watch these things, they're helpful in guiding me in future things when I'm doing different things, because everything that we do with registration is different. Your atmosphere is going to be completely different from my atmosphere. I have a training system just dedicated with a wheel on it. Basically, I'm using the photo eye when it sees the reflector, that's my trigger. Instead, you could be having it where you have a photo wire that's giving the signal back, and when it breaks the signal, it could be then giving you your registration bit. That's completely opposite of what my scenario is. So I'm making this exactly how I have the system and how I can transition this. Again, that's coming in using a simple registration event, and that's coming in doing that. So I wanted to make that quick video to show that and show how this is working, how the current system is working with my process, and why I'm doing certain things. So with all that said, hopefully that was helpful, valuable, and is guiding you and giving you a little bit more information about how registration input is done, how servos interpret the registration input if you're using a positive edge, negative edge, how you use two together, again, when it comes down to it, and also why it's important to do event-driven when it comes to doing different things. Again, I'm a fan of periodic tasks, but I wanted to show an event-driven system and how you should interpret an event-driven system, because again, when it comes down to it, it's very important to understand both, because not every machine uses exactly one or the other, but when it comes down to it, understanding both really is helpful in growing and moving forward. Understanding your systems. Everybody's system is going to be different, so please take this video, get the little tidbits that you learn from it, implement those into things you are using inside of your machine, and hopefully this gives you some valuable tips to actually get better registration. Okay, with that said, see you guys on the next one.